experiment, you would synthesize two different products. One is tris 2,4-pentane dianatto-cobalt 3. The other sample is tris 1,1,1-trifluoro 2,4-pentane dianatto-cobalt 3. The second sample that you prepare is actually a mixture of isomers. And in order to isolate the separate isomers, a column is being used to accomplish that task. The silica in the column is polar, so the two isomers have different polarities, and as a result, by making use of the column, we can separate the two isomers and isolate them and make other measurements on them should we wish to do so.
So we're going to start packing the column here now. When I pack my columns, I like to start with a little piece of cotton at the bottom so the silica doesn't run out through with the solvent. So I have my cotton in there now, and the next thing I want to do is get a nice layer of sand there. You only want enough so that the silica isn't sitting directly on the cotton plug. So once you have your sand there, you can give it a little tap to get it as flat and even as possible. That way when the product elutes out through, you don't get a running of the two bands in between the bottom. So the next thing that we're going to want to do is actually load the silica onto the column. There are a couple different ways that you can do this. I personally like to use what's called the slurry method. So that's a mixing of our silica gel and the solvent that we'll be using to elute. In this case, it will be toluene. I like to start with a little bit of silica because it roughly doubles when you add solvent. So it's easier to add more silica later. It's harder to take the silica out. So once you have your solvent added, you can give it a stir. And like the method name suggests, you will make a slurry of your solvent and silica gel. So the next thing we're going to do is just run some solvent through the column so we're able to get the silica gel nice and tightly packed before we load our sample onto it. So now that we have our column packed with our silica, we're going to load our sample. Like packing the column, there are a couple different ways to load the sample. I like to do what's called wet loading. There's also dry loading, it's another common one. So to do so, we want to take some of our sample and dissolve it into our eluting solvent. We want to try and use as little of solvent as possible, just to make the loading easier. Just swirl to make sure it's all dissolved. And once it's dissolved, you just load onto the column. While it's loading, we'll start eluting. That way we can load it all on nicely, and we can recycle some of our solvent up until our bands start to elute. So as you can see, our band has started to form here, and what we want to do next is fill up our column with solvent so it can run. When we're filling the column with solvent, we need to be careful not to disturb the beginning of our band. So I slowly load in about an inch of solvent, and then you can quickly pour as it won't bother the line at that point. You also need to be very careful not to allow your column to run dry. If you allow your column to run dry, it's not going to run evenly and separation will be very poor. So once you have a little bit of a solvent layer built up, you can gently pour from the top, and you should try and get it to run down the sides to not disturb it. You can also begin to notice the band is separating into two separate ones, so that's the start of our separation. So our first band has completely separated and has come down past our layer of sand and cotton. We can see our solution here is really dark. To prevent any cross-contamination, any of the second band bleeding into first, we'll switch into a separate Erlenmeyer now. We'll collect a small volume of the in-between region, and when our band here probably gets another minute or so, we'll start to collect the second band to get two pure products. We've collected a few mils of our intermediate between the two, and it's been long enough that I think we're collecting all of our second layer here now. So we'll just let that run for a few extra minutes to make sure anything else is there gets flushed out. Our second sample is pretty much done, so we're just going to let the rest of the solvent run through to flush out the system. To make sure there's no extra impurities or residual starting materials, we'll just switch it out to a different beaker, and that way we should have two nice pure products.